So this is an external beam radiation linear accelerator made by a company called Varian. This is the true beam model. This is our newest linear accelerator we've got. Everything starts off as electrons. So without electrons, without electron gun, nothing works. So we start off by generating electrons via thermionic emission. This comes from the electron gun, which is in this part of the machine here. This big part that rotates around is called the gantry. The rear part here is called the stand. The stand contains all the control electronics, the brains of the machine. So we generate a very high DC pulse, which we then send to something called a klystron, which generates an RF microwave power, typically around 20 megawatts. We inject that into the accelerator guide. So actually the accelerator, this is a linear accelerator, shortened to a LINAC, the name. The actual accelerator guide is only in this top part here. It's about 4 foot long, and we inject the microwave RF power into the back end of it, and we coincide that with electrons which are generated from the electron gun, which is generated by thermionic emission. And that coincidence of those two, the electrons and that RF power, accelerates the electrons through the accelerator guide. And we inject them in at about 0.4 the speed of light at this end. And we accelerate them all the way up to almost the speed of light. Almost the speed of light. We then turn them through 90 degrees because the patients will be positioned on the couch here. And we turn them through 90 degrees with bending magnets. And then most of our patients we treat with photons, high energy X-rays. So we have to create that by driving the electrons into a tungsten target, and that liberates high energy X-rays, which we use to treat the patients. We then shape and focus the photon beam directly through to the patient, and we first of all we collimate it to make it a smaller size. And then the last thing is we use something called a MLC, multi-leaf collimator, which is a series of 120 tungsten leaves, which are about the size of my hand, and they're all an interference fit, so they're next to each other. And we shape them. It's like one of those tools you might use for plumbing or something, where you want to get an intricate shape, and the little fingers come out and it makes that intricate shape, and you can cut a tile out. And that's very similar to what an MLC, a multi-leaf collimator, is. And then we project that down onto the patient, and we target just the tumour, just the cancer, and we protect all the other cells around. So what happens is then the photons then interact with the DNA. So these machines are designed to biologically disrupt the DNA of cells. So if we break that double link chain of a cell, the cell should die. But we have to deliver it in a controlled manner because we can't deliver the total amount of energy that a patient might need. So the patient comes back for multiple treatments. They're divided into fractions. It's called fractionated treatment. So they'll have a certain amount one day, a certain amount another day. And patients can come back for maybe, the most would be about 32 days of consecutive treatment. But we might have just single fraction treatments where the patient just has one treatment in a day. They shouldn't, in theory, feel anything. They might feel a slight sensation of more like a sunburn type feeling, but in theory shouldn't feel anything, or you don't feel anything. I certainly didn't when I was a patient here, some 20 years ago. But we can get every angle from every angle. So the gantry, I'll show you, moves around. So the patient would be on the couch, and then the gantry would be rotating across the top of them. This weighs about 5 tons in weight. There's a lot of lead shielding on here. But we do occasionally get patients who are interested to see the linear accelerator before their treatment, and I think it's a really good thing for them to see, because it gives them confidence that when the big thing's rotating around them, they know they're not going to be touched by it. It's a non-contact thing. It never touches the patient. So you can see the collimator here rotates around as well. And if you look carefully in here, if I do this, you should see down here, these points over here are all the leaves, the multi-leaf collimator, where my finger is there. This is the leaves here, and they all extend outwards into here.